Assalamualaikum warahmatullahi wabarakatuh. Today we will continue our lecture on simplifying expression using Boolean Algebra. So for today's lecture, I will show you some examples how we can simplify the expressions by using Boolean Algebra theorems. Okay, for example 1, this is the question. Okay, so you need to simplify y. Okay, y equals to a bar plus bc, okay, plus with a bar and b and c. So this is the questions. Okay. So how you can simplify these expressions? So first, this expression is SOP expression, right? So you must remember for the first part that we learned in chapter 3, which is the two types of expressions that we have, SOP and also post. So this example 1 is SOP expression. Most of SOP expressions we can start by factorizing the expressions. Okay, but for this example we cannot factorize, okay, because there are no similar variables that we can use as our factorized value, right? Okay. So if you can refer to this question, the first term you have a bar. Okay, for second terms you have three variables a and b and c. So there are no similar variables. So that's why we cannot factorize the expression. So what you can do, you can refer to this solution. So the first step is actually we proceed with the Boolean algebra theorems. So you need to understand, you need to find what is the theorem that you can use to start your steps. Okay. So in this solution, okay, we start our step, okay, by using theorem 10. Okay, if you can refer in your manual, so theorem number 10. Okay. So what is theorem number 10? So I write here. So theorem 10 says that if you see this kind of equation, which is you have different variable for both terms, a plus b and c. So what you can apply for theorem 10 is you can expand. Actually, theorem 10 says you that you can expand the expression, or you can change your expression from SOP to post. So you will get this expression, okay, a plus b, a plus c. So this is theorem 10. So for the solution, it used theorem 10 for the first step. Okay. Why we start with theorem 10? Okay, because if you can see in the question, okay, you have a bar and you have a. Okay, so we want to extract these two variables. Okay, so how we can extract these two variables? By applying the theorem 10. So when you apply theorem 10, you will get these expressions. Okay, a bar plus a bar plus bc. Okay, so when you get these equations, it shows you that a bar plus a is become one term. Okay, become one term. Okay. So we change actually from SOP to post. Okay, so that is a function of theorem 10. So when we apply theorem 10, so what we will do next is we find other theorems that we can simplify the expressions. Okay, so this is another theorem that we can apply, okay, which is for the first term between a bar plus a. So a bar plus a is equal to 1. So this is another theorem that you have in the list, okay, for Boolean algebra theorems. Okay, so a bar plus a is equal to 1, and then for the next step is between these two value. So this is another theorem, 1 times with a bar plus bc. So what happened? Okay, so you will get a bar plus bc. So this is another theorem. So your last answer will be A bar plus BC. Okay. So for this example, it shows you that when you use your theorem 10, okay, you start with your theorem 10. So in theorem 10 actually is come with another two theorems. It can along together with theorem 10, right? Okay, this theorem, sorry, A bar plus A, and these theorems. Okay, 1 times A bar plus BC. Okay, so your last answer will be A bar plus BC. Right. So before I continue with the second example, okay, for the first step, okay, which is the theorem 10. So if you can see your expressions that you get after you apply theorem 10, you have two terms, right? A bar plus A and A bar plus BC. So if you refer to your manual, okay, for theorem 10, you also can expand for the last terms here, which is between A bar plus BC. Okay, that is another step. Okay, but in this case, okay, you don't have to expand, okay, for this term. Okay, why? Because our objective here is to simplify the expressions. So thus expanding these terms will simplify your expressions? No, right? So that's why you just expand, or you just apply theorem 10 once. Yeah, just expand between A bar plus A and A bar plus BC. So that's it. You don't have to expand for these expressions. Okay, so the most important part for simplifying expression is actually you need to choose the suitable theorems so that theorems will simplify your expressions. If you use that theorems but it does not it did not affect your theorems, your expression at all, meaning that it not simplified the expressions, so maybe you actually use the wrong theorems, okay, not suitable for that expressions, so you may choose another theorems. Okay, that is a purpose of applying the Boolean Algebra theorem, so that we will simplify the expression. So whatever you do, okay, in your process, you have to make sure that your step will simplify. Simplify here meaning that some of your, maybe one or more than one of your variable in your expression will be removed. That is simplify. Okay, so we've done with our first example. Okay, so we will look at for the second example. Okay, so this is a second example. Okay, so simplify y equals to a plus a bar and b plus a bar and b and c. So this expression is a bit longer compared to our first example, right? So what is your first step? Okay, so as I mentioned earlier, if you are given the SOP expressions, so maybe you can start with factorizing. Yeah, factorizing the expressions, or you can apply theorem 11, right? Factorizing is actually in theorem 11, so that when you factorize, it will simplify, or will remove, or it will delete some of your variables, right? So here there are two solutions, okay, that you can apply to simplify the expressions. Okay, maybe there are another solutions, but I only show you these two solutions. Okay, so we look at our first solutions. So in our first solution, we apply theorem 11, which is factorizing, okay, between a bar and b, okay, between a bar and b, okay, plus with a bar and b and c. So we factorize between those two terms. Okay, so when you apply theorem 11, you will get a bar and b, okay, as your simplified term. So this is the factorizing, right? You take out the similar variables. So here you have two similar variables, a bar and b. Here also you have a bar and b. So your factorized value will become your last, or your answer for factorized, or for your simplified. Okay, so that's why sorry, you will get a bar plus a bar and b, okay, as your last solution for factorize. Okay? So for a, okay, you just drop the value of a, because it not included in the process of factorizing. Okay? So next step, okay, so what will you do? Okay, it's actually you apply theorem 10. So here is actually theorem 10. Okay, you apply theorem 10 for this equation. Okay. Why we apply theorem 10? Because we want to create these terms. Okay, as I mentioned earlier, whenever you see the expression that have this kind of value, which is you have a and here you have a bar, or here you have a bar, here you have a. Yeah, so you can use theorem 10. Okay, when you use theorem 10, so you will expand the expression, so you will get these two sum terms. Okay, so a bar plus a plus a bar, and second term is a plus b. Okay, and then you simplify, you apply another theorem, which is a plus a bar, you will have 1, and then this is also another theorem, 1 times with a and a plus b, so you will get a plus b. So this is for first solution, how you can solve your problems. Okay, we look at the second solution. Okay, for second solution is the solution not start with factorizing. Okay, start with apply the theorem 10. Okay, so actually theorem factorizing is also in the theorem, right? Theorem 11, but here we use theorem 10 for our first step. Okay, between the first two terms, okay, a plus a bar and b. Okay, so a bar and b and c you just drop, or you just carry, okay, the value, because the variables the terms is not involved in our first step. So after you apply theorem 10 for the first two terms here, so you will get these equations, a plus a bar, a plus a bar times with a plus b. Okay, and then a plus a bar times with a plus b, the simplified value, you will have a plus b. So this is a simplified step. Yeah, so actually between this step you have the similar step here, quite similar, which is you will have 1. Okay, you will have 1 times a plus b. Okay, so that is a similar. Okay, but I just remove that step, so I just put the simplified value. Alright, so next, okay, what you can do, okay, after you solve your first theorem, which is theorem 10. Okay, so again we apply theorem 10. Okay, between a and a bar and b and c. Okay, so b you just drop at back. Yeah, so you apply theorem 10, so you will get this equation, a plus a bar, a plus b, c. Okay, and then the simplified equation for these two terms, okay, you will get a plus bc. Okay, so how you can get that one is actually from this simplified 1 time with a plus bc, so you will get this one. Okay, a plus bc, because 1 times with a plus bc, you will get a plus bc. Alright, so next step, which is our last step, is theorem 11 of you factorize between b and c plus b. Okay, because you have similar variable here, you have b and you have b here. So you factorize b, yeah, so you will the value in the bracket will be c plus 1. Okay, so c plus 1 is 1, right? Yeah, c plus 1 is 1. Okay, 1 times with b, you will get b, so your last answer also will have a plus b. So this is a two solutions that you can apply for the simplifying process. So based on the solutions, of course, you will have the same answer. So no matter what kind of theorems that you use for your first start, you need to have the same answer because you are given the same questions, right? Right. So this is the second example. So maybe you have another solution, so it's okay, you can apply whatever step, whatever solution here, as long as you apply the correct theorems, and then you will get the correct answer. Yeah, so that is for second example. Okay, next we go for the third example. So this is our third example. Proof. Okay, the question of proving is actually easier, okay, than the question of simplifying, because proving you already have the answer. Okay, the last answer. For example, for this question, prove that the SOP and post expression for an OR gate are equivalent. So you are given two equations, SOP and post. So what you need to do is actually you need to simplify SOP, okay, until you get post expressions. So meaning that until you get these expressions. Okay, so this will be your answer. So that's why I told you that proving is actually easier than simplifying, and because you already have the answer. So we look at the solutions. So based on the solutions, this is a suggested solution, so maybe you can have another solutions, right? So for the first step is we applying the theorem 11, or factorizing actually, okay, between the last two, okay, between a and b bar plus a and b, because both equation have a, okay, which is the similar variables. So after you factorize, your answer will be your factorized value. That is the theorem 11 said. Yeah, so whatever factorized value, okay, that you have, okay, in your factorizing, so that value will be your last answer. Yeah, so that's why you have a. Okay, and then next step, okay, between a bar and b plus with a, so you apply theorem 10. Okay, because we want to create these terms between a bar and also a. Okay, so when you apply theorem 10, you will get a plus a bar, a plus with b. Okay, so this is theorem 10. Okay, a plus a bar, a plus a plus b. Okay, so a plus a bar is 1. 1 times, okay, 1 times with a plus b, sorry, okay, 1 times with a plus b, so you will get a plus b. Okay, so this is the solution, okay, for proving, okay, the SOP expression is equal to post expressions. Okay, so I will show you another solution, okay, for these questions. Sorry. Okay, so I show you another solution. Okay, for first solution, we start with the last two terms, right? Okay, for my suggested solution, so this is another solution, how you can solve the problems. Okay, which is I start between first and last. Okay, so I want to factorize, okay, for both equations. Okay, So based on both terms, okay, based on both terms, you have similar variable which is b, right? So you can factorize b. So in bracket will be a bar plus a, and then here we will get a and b bar. So a and b bar, you just drop the equations. So a bar plus a is 1, another theorems. 1 times with b is another theorem, so you will get b as your last terms, okay, plus with a, b bar. Okay, so next step, what you can do for these equations is actually the same step here. You apply theorem 10. Okay, so when you apply theorem 10, meaning that you will expand the equations, okay, b time with a and then b time with b bar. So you will get b plus a time with b plus b bar. Okay, b plus a, okay, time with b plus b bar. Okay, so b plus b bar is 1. 1 times with b plus a, you will get b plus a, or is equal to a plus b. Okay, so if you can refer for my solutions, also will get the same answer, okay, which is a plus b. So as I mentioned earlier, no matter how you solve your equations, as long as you use the correct theorems, and you will get the correct answer. Okay, so that is for our third example. So we look for the next example, which is example number 4. Okay, so this is also the proving. Okay, prove the SOP and post expression for an AND gate are equivalent. So you are given two expression, post and SOP. Yeah, so as I told you earlier, if you are given the post expression and then you need to simplify the post expression, so the first step for simplifying post expression is actually you need to expand. So that's why here you can refer, okay, the first step you expand the expressions. Okay, so because we have three sum terms, a plus b bar, a bar plus b, so you can choose either two, okay, to expand the expression. Okay, so based on this step, you will expand for the first two sum terms. Okay, so these two sum terms will be expanded first. Okay, for a bar plus b, you just drop the terms, okay, because it's not included in the process of expanding. So you just expand, so you will get this expression, which is a and a plus a and b bar plus a and b plus b and b bar. So you need to times variable for each variable. So that's why you have these terms. Okay, so these equations. Alright, so after you expand the equations, what you can do is actually you can simplify, okay, the terms that have in your equations, okay, after you expand. Okay, for example here, a and a bar, so you will get a, right? B and b bar, so you will get 0. So this is another step. Okay, you just solve, okay, the problems inside the bracket. Okay, and then next you also can apply the theorem, which is because you have plus 0, right? So whatever value that you plus with 0, so you will get the same value. So this is your value. Okay, so you will get a plus a and b bar plus a and b, meaning that you just remove the 0. That's it for plus. Okay, and then next, yeah, still in our first bracket, yeah, which is it factorize a. So this is the first bracket. Okay, so this is still in the first bracket for the first one. Okay, so a bar plus b, you just drop, okay, the value. So when you factorize a, meaning that you apply theorem 11, right? Factorizing is actually you applying theorem 11. Okay, so you will get a, okay, as your last value for factorized. So this is a step. Okay, this is a step. Okay, this is a step. Okay, for factorizing. So you will get a. And then next step, okay, you will expand the expression with our last term, okay, which is a bar plus b. Yeah, so a bar plus b. So you just expand, okay, you times, yeah, so you will get a and a bar plus a and b, and you apply the theorem, which is a and b, a bar is 0, right? So you will get 0, and then 0 plus ab is another theorem, so you will get a and b. So this is the step, okay, how you can simplify the post expression. So for post expression, you need to start with expanding the expressions. Yes, you can choose which terms that you need to expand, you want to expand. Okay, because here you have you have three terms, yeah, three sum terms, so you can choose either two, okay, to expand. Okay, not necessarily between these first two, so maybe you can expand between the last two, or maybe for first and last, so either two. Okay, because this is a post, right? So the sign is same, which is all and or multiply, so you can choose which sum terms that you can expand. Yeah, so this is the example 4. Yeah, so I hope you can get the idea, the process of simplifying expressions, okay, using Boolean algebra, based on all 4 examples that I already explained. Okay.